Hey guys, Persistent Programmer here and welcome back to my channel. So in this channel we solve a lot of algorithms and go over Leetcode questions. So if you haven't subscribed already, go ahead and hit the subscribe button, smash that like button because that helps me create this content for you guys. So without further ado, let's go ahead and look at today's problem. Today we're looking at the binary tree preorder traversal iterative implementation. Now I have already posted a recursive implementation of this and I will put one of the cards up there if you're interested to watch that. So today we're going to use a stack and we will traverse this tree using the preorder traversal, which is the node left right. So let's go ahead and get started. The sequence here, so we need to check the node first and then the left right. So let's manually go through this and fill out our results list here. So first of all, I will process the node, so that is 3, and then I will look to the left here. So I've processed the node, I will look to the left, and the left is 9. And again, we need to process this node first, 9. So I will put that here. Now I need to look at 9's left and right. So 9's left and right are none. That's fine, but I do not want to include this in my res. That's fine that there are none, but we do not need to put none and none in the res. So that's fine, we can say that the left side of 9 is done and the right side of 9 is done. Next we will look at the 3's right here. So we're here at 20, and again we need to process this node first, so we will say 20, and then 20's left is 15 here. So again, I'm at 15 and I will process this node first. So I will put in here 15. And then again, we have 15's left, which is none, and 15's right, which is none. That's fine. We just don't need to include it in our res here. So next we will look at, we've finished processing 20's right. We'll look at 20's, we've finished processing 20's left. Now we will look at 20's right. So at 20's right, we have 7, and we need to process this node first. So we'll say 7, and 7's left is none, and 7's right is also none. And that's fine, we just don't need to include this in our list. So this is the this is the result that we want to return going in the pre-order sequence. The way a stack operates is it uses the LIFO principle, which is the last in, first out. Now what we can use is we can send a root's right node in the stack first. So we can, let's say we're processing this tree. So we can send in this node, the 20, first as the right node, and then we can send the left node after that, which is the 9, right? So what happens is when we are pulling out from the stack, we're pulling the last one sent in. So 9 would be processed before 20, which is the order we want. So let's go through an example with this binary tree and see how the stack would operate and how it would populate the result. I have some pseudocode here that we can follow to make sure that we are processing the elements in the correct order. So here what I've done is I have put the initialize the stack with the root in it. So this is a 3, and then while stack is not null, what is going to happen is we're going to pop the elements out one by one. So at first we're going to pop the 3 because that is the root. So I have put that in my res here. And then we are going to check, hey, is this node null or not? So if the node is not null, what we need to do is we are going to put in the node.val, which is what we've done here, 3. And then we are going to process we're going to put into the stack the right and the left child. So we're putting the right first because we want to have access to our left element and pop that out in the next iteration. So that is why we're doing that. So here I have 20 and 9. Now this is going to go back into the top of the while loop again and check, hey, is the stack null? So this is our stack node is not null because we have the 9 and 20 now. And then we're going to pop. So when we pop this node, we're checking, hey, is this node null? So no, this is not null. This is our 9 node, right? So what we do is we store that node's value in the res, in the result. So we are going to do that here. So we'll put the 9 here, and we have processed this. We're done. Now what's going to happen is we're going to put the 9's right and left child. So 9's right is a none, and 9's left is also a none. Okay, so we are going to put that here. So this is going to be, we have processed this already, so this is not there, so we're going to put in the none and the none here. Okay, so in the next iteration, what's going to happen is we're just going to pop these nones, but we are not going to go into this if condition. So what we don't want is our res to be filled with none and none, right? So that is fine. We're just going to keep popping them, so that's fine. So while st, so st has elements in it, so we are going to keep popping these two. So after we're done popping these two, now we're finally at the 20. And what's going to happen in this stage is we are going to evaluate what we need to do. So if node, so now we have processed the nones and we are going into this if condition. So if node res equals node.val. So we are going to put this 20 up here. So now we have processed this 20 because the order is the node left, right? And what's going to happen next is we are going to put in, let me just create a fresh stack over here just so it's easier to see. So now we're going to put in 20's right first, which is going to be the 7. And then we will put in 20's left here, 15, just because we want to access this first, right? So again, same idea. What's going to happen now is in the next iteration, we're going to pop from this stack. So we will pop this 15. So we are going to pop this 15 and we're going to add this to the res. So res equals node.val. So we're going to add res.append node.val. This is just pseudocode. I haven't really followed like proper syntax here, but you get the idea. So we're going to pop this one here and we will put this over here. So 15. Okay, so we have processed this node. Now again, we are going to go to 15's right and left, which are both none. So that's fine. We're going to put that in the stack here. So we're adding the left and right here. So none and none. And again, we're going to pop those two out. So we will pop these out, and that's fine. We just are not adding it to our res here. And then in the last iteration, we're finally at 7. Now if node, which is currently we have our 7 that is popped here in the last in the last node value, and if node, we are going to add this to our result. So result equals result.append is node.value. So we're going to put this up here. And then it's going to go ahead and process the nones here, which we just don't add to our res here. So this is how we're getting our res final result of this pre-order traversal. Now let's go ahead and write the code. Okay, awesome. So I'm back in Leetcode, and what I've done here is I have initialized my results list here, and I have also initialized the stack here with the root. So while stack, what I want to do is say node equals st.pop, and this is how we're getting out the node. And then I want to say if node, so if the node is not none, then we're going to process it and put it in the res. So res.append, and we will put in the node.value here. Okay, next what we want to do is put in the right, process the rights of tree first. So I will say stack.append, and we are going to put in the right side of the node, so node.right. And then we're going to put in the stack the left side, so stack.append, and we will say node.left. Okay, and then we are finally going to return res. Let's give this a run. Okay, awesome, accepted and submit. Yay, success.